All right. So we'll have a brief time at the end. If we have extra time, we can follow up with some more questions and stuff and have some more discussion. But I think we'll go ahead and transition directly to the talk. So Dan Luhring from Anchore, you want to go ahead and take it away here?
Sounds good.
The presentation.
Excellent. Yeah, let me share my screen. Hello, everyone. I'm Dan Luhring, engineering manager for open source at Anchore. All right, so hopefully everyone can see the slide here. I'm actually pretty excited about this talk because this is kind of like a tale of two projects, Flux and Syft. And we're going to talk about a few different things throughout this talk. We're going to talk about both Flux and Syft, and also what an SBOM is and how that's kind of the glue between these two projects, and then how we can use SBOMs and integrate them pretty easily. But I think we want to start with talking about Flux, because for the Anchore meetup, I think we've talked about Syft a few times. So hopefully some people are pretty familiar with Syft. If not, we'll go over it. But I think what's particularly interesting to start out with to kind of set the stage is Flux. What is Flux? Why does Flux exist? And then that'll be a great segue into the rest of the talk. So for that, I'm going to hand it off to Pinky to talk about GitOps and Flux.
Yeah, so sorry, I'll be just giving like a brief introduction to GitOps and Flux. I am Priyanka Ravi. I also go by Pinky, and I am a developer experience engineer at Weaveworks. Just go to the next one, Dan. You're good. Okay, so what even is GitOps, right? So GitOps is actually an operating model for cloud native applications such as Kubernetes, but I do want to highlight that it's not just for Kubernetes. If you are doing a multi-cloud infrastructure, you can still use GitOps, but since we're focusing on Flux, we'll be talking about Kubernetes. GitOps also utilizes a version controlled system, most commonly Git, as the single source of truth. It enables continuous delivery through automated deployment, monitoring, and management by a version controlled system. And basically with GitOps, you manage your infrastructure and applications declaratively. So there's these 4 GitOps principles, and what they are is basically a set of best practices that have been defined through discussions with many different vendors and users by the GitOps working group. And if you're interested in that and you want to know more about it, you can go to opengitops.dev to learn more. But don't feel like you have to have them all done in order to use GitOps. Everyone's journey is different, and you can start using GitOps and add in hardening and tweak your setup to meet these guidelines as you go. But basically, the first principle is that a system managed by GitOps must have its desired state expressed declaratively. And there's a lot of benefits that come with doing that as well. If things are written in code, they're more reusable, there's an audit trail, and you can also know right away what should be out in production if you have it written in code. The second one is that a desired state is stored in a way that enforces immutability, versioning, and retains a complete version history. There's no sneaking in a change. Everything has like an audit trail. The third one is that software agents automatically pull the desired state declarations from the source. And the fourth one is that software agents continuously observe actual system state and attempt to apply the desired state. So basically what that means is you have something that is actually checking to see what your desired state declarations are from your source, such as Git, and then actually continuously checking what is actually out there and attempting to apply the desired state. So you get away from things like configuration drift. If something gets out of sync, it'll automatically apply it. All right, so why GitOps? What value does it bring? Individuals, teams, and organizations who implement GitOps experience many benefits, including stronger security guarantees. Because of GitOps's tool's unique ability to treat everything as code, basically it creates a direct impact on security. For example, if all configuration and security policy is treated as code, everything can be held in version control. So any and all changes that are made are reviewed and input into an automated pipeline. There's no manual processes. So because of that, it actually increases developer and operational productivity, and it enhances the developer experience. You're less likely to maybe be at work on a weekend because of some manual issue that happened and some error that happened because of some human error. And because of all these things, you have improved stability, higher reliability, and consistency and standardization. Now, I do want to stop here briefly and just see if there's any questions on GitOps as a whole, just as a concept, before we move on to what Flux actually is. I don't see any, so I don't know if there are any yet. If not, we can move on. Let's just move on to Flux. No, I don't know. Oh, that's Zach. Okay. So what is Flux? Flux is a Git-centric package manager for your applications, but Git isn't technically the only system you can use, but it provides a set of continuous and progressive delivery solutions for Kubernetes. It is a natural extension of the benefits of Kubernetes. And basically at the core of it, it continuously monitors your version controlled system and it applies the desired state that's been declaratively stated there. The nice part of this is that you don't have to worry about configuration drift because it reconciles on a schedule. So if things have gotten out of sync for some reason, it will actually set it back to the desired state. Flux really reduces developer burden because it removes the need for manual deployment processes. And also the Flux command line tool is a convenient way to bootstrap the system in a cluster and to access the custom resources that make up the API. And then there are these, next slide, Dan. Thank you. There are these 8 things that basically we like for people to know about Flux, just like a Flux in short kind of thing. So the first one is that Flux provides GitOps for both apps and infrastructure. Using Flux and Flagger, you can actually deploy apps with canaries, feature flags, and A/B rollouts. Flux can also manage any Kubernetes resource, and infrastructure and workload dependency management is built in. You just push to Git and Flux does the rest. It basically manages deployments through automatic reconciliation. It also works with your existing tools. So it works with your Git providers, GitHub, GitLab, Bitbucket, can even actually, so this is what I was mentioning earlier. It doesn't really have to be Git. You can even use S3 compatible buckets as a source with Flux. It works with all major container registries and all CI workflow providers as well. And it works with any Kubernetes and all common Kubernetes tooling. Customize, Helm, RBAC, and policy-driven validations such as OPA, Kyverno, admission controllers. It really just falls into place with your existing setup. Flux does multi-tenancy, and we like to say multi-everything. So Flux uses true Kubernetes RBAC via impersonation and supports multiple Git repositories. Multi-cluster infrastructure and apps work out of the box with Cluster API. Flux can use one Kubernetes cluster to manage apps in either the same or other clusters, spin up additional clusters themselves, and manage clusters, including lifecycle and fleets. Flux also alerts and notifies. So it provides health assessments, alerting to external systems, and external events handling. You basically just Git push and get notified on Slack and other chat systems. Users trust Flux, and you will see later why that is. And then also Flux has a lovely community that is very easy to work with. We welcome contributors of any kind. The components of Flux are on Kubernetes core controller runtime. So anyone can contribute and its functionality can be extended very easily. All right, so what are the benefits of Flux? I mentioned earlier, it reduces developer burden. It basically also removes the kube control problem of you don't have to worry about kube control versions to be able to interact with the cluster. It's also extensible. It's really versatile. It works with existing tools. It's flexible, modular, and a natural extension of Kubernetes. It's also extendable because of the microservice architecture. You can pick and choose what you want to use to tailor your own experience, basically. And it comes with out-of-the-box support for Customize and Helm, and it's designed for Kubernetes in mind. So it really will work with your already existing ecosystem. Now, Flux is actually developed with a microservice architecture. It's basically a set of Kubernetes controllers. And if you're not familiar with controllers, a controller handles the lifecycle of objects in Kubernetes, basically what should be done when an object is created, updated, deleted, etc. So, and then I'm going to go into what these actual controllers do. So basically, the source controller just fetches resources and stores them as artifacts from your source, whatever you've set, your Git source. And then the customized controller actually applies manifests and runs manifest generation using Customize. The Helm controller does deployment of Helm charts, and the notification controller handles notification dispatch. The image reflector controller and the image automation controller basically work together to update a Git repository when new container images are available. And it really works with so many other tools. The list goes on and on. These are just a few that we wanted to mention, but yeah, there's a bunch of tools that it works with. And then if you want to get started with GitOps and Flux, there's some links here. fluxcd.io/doc/get-started is a good place to start. And I'll wait and see if there are any questions for Flux. Is there's some there? So I myself am not a user of Argo. I've never used it. I actually have only used Flux in my career, so I'm not very sure. You could definitely ask that question though in our community, and you probably get like more information. So there is information on how to set up S3 as a source. It's in our documentation. I can maybe pull up a link to it and send it to you. Yeah. So yes, exactly. You would use it basically the same way. You would just upload your manifest, and then Flux would basically be looking there for any YAMLs or whatever. Yeah. I'll find it and then I'll link it to you. I'm not sure where it is off the top of my head. Oh, sorry. I know I was supposed to actually read the questions out loud. Sorry, Zach. Basically,
No worries.
the question was like, how does using it with S3 work? And so, yeah.
Great. And is there a link for any Flux comparison with Argo or Rancher that we can follow up with, like in the chat, maybe a little bit later? That might be one way to help that question. We'll see.
Not that I know of off the top of my head, but I'm sure it's out there. Yeah, I'm not sure about it. I can see. Like I said, I think it was like, yeah, I would also suggest like asking it in like the GitOps CNCF Slack or something like that.
Excellent, thanks. Any other questions?
And oh, sorry, the other question, Helm OCI support works too in the Helm control. I think it's something that's being worked on. I don't remember if it's already actually released, but I know it is something that is in the works. So I'm not sure about that one. All right, and now we are going to actually hand it over to Brady, who is going to actually talk about how he uses Flux at Anchore.
Hey everyone, I'm Brady Todd-Hunter. I'm the tech lead of the engineering ops group at Anchore. I'm just gonna do a brief overview of how we use Flux and then take some questions afterwards. We use Flux on two separate internal clusters. The first cluster that we use is our production Anchore cluster. It's the cluster that we run Anchore on. And that cluster is set up using our production Helm repository. So our normal Helm repository that all of our customers would use. And it's using all of our production images. And it just updates whenever we do deployments. And that is the cluster that we use for scanning our images in our pipeline. And then we also use it on our development testing cluster. And that testing cluster is running multiple different development environments. So on those environments, they are all set up a little bit differently. I already talked about how our production Anchore cluster is using our production Helm repo and image repos. Our testing cluster is set up. We have some environments setting up using our production repos. Then we have some environments set up using a Helm Git repository, like a development Helm Git repository, as well as the development image repositories. And then we have multiple different branches in our Helm repository or Git repository that get pulled from. In all of our testing environments, we use the image automation controller, and that is used for automatically watching our repositories and pulling new images when they get pushed up. So, and then updating our Flux Git repository with those images in them. The image automation, the way that works is we have some regexes on our different Helm deployments that are watching very specific image tags. And those image tags are created via our CI pipelines based on Git tags. So when we push certain Git tags, it creates images using those same tags. And then our image automation is watching for those tags and updating our different environments. For example, we have like release candidate environment, a nightly environment, a sprint preview environment, and all of those get different tags, and the image automation controller is watching for those tags. And that pretty much describes, like in a nutshell, how we're using Flux. The things that I really love about Flux is the developer empowerment. So we have our testing cluster that has its own repository that holds all of our Kubernetes manifests and Helm deployments. And we're able to manage that cluster using just normal GitHub teams to provide access to it. And developers can just put in PRs to make changes to the deployments. So that makes it really easy for developers to change what the environments look like without having to like go onto the cluster and change things. And as also by having the PR so that people can review it and make sure things aren't crazy and break all the environments. The next thing I love about it is the flexibility. So I talked about how our different environments are set up using different repositories. So I really like that we can point one environment to our production Helm repository, another environment to development Git repository that stores Helm charts, another environment to a branch on that Git repository. And then some environments are just spun up using Kubernetes manifests directly. So a lot of our like monitoring and logging is all set up just using Kubernetes manifests. The next thing I like about it is that it's a source of truth for all of our deployments. So if I need to know what is deployed to each environment, or a developer needs to know what is deployed to each environment, we can just go look at that Git repository. And I have it organized by namespace. So you can just like look at the namespace and see exactly what's deployed to that namespace. And it also kind of provides like a change log. You can look through the Git history and see what has changed, who made those changes, and when they happened. And then the last thing I like is that it uses native Kubernetes mechanisms. So I'm an ops guy. I live in the terminal, and I really like that I can just describe a custom resource and see what's happening with my deployment using that. I don't have to, like, I prefer not to open a UI or use a different tool. I just use the tooling that I'm used to using all the time. And then, of course, I love that it's like magic. I just push things to my Git repository and it ends up on my Kubernetes cluster, which is every time it happens, I'm like, oh, this is amazing. So that's it for me. If anybody has any questions, I'd be happy to take those right now. Checking out. Looks like none of these questions are for me. I'll give a couple more seconds. All right, and now I'm going to hand it back off to Dan Luhring to talk about Syft.
I think there is a question about monitoring real fast.
Oh.
No. Are you using monitoring with it, Brady?
Using monitor. So we have Prometheus running on our clusters that are watching all of our deployments. Are you talking monitoring about Flux, or monitoring Flux itself and how?
Not sure what they're asking specifically, but there is a whole section on our Flux docs too about setting up monitoring. Yeah, so there's a whole section about like if you want to actually set up monitoring with Flux. It's pretty easy. I've done it myself too. And yeah, so it's super simple.
For secrets management, I'm using Sealed Secrets by Bitnami. So that is, I deploy Flux using Terraform, and then I'm building out the sealed secrets using a Terraform module that I wrote. So I deploy sealed secrets to my cluster using Flux, and then using the key pair that sealed secrets creates when it's deployed, we encrypt our secrets, and then I just push those encrypted secrets up to my Git repository to be synchronized to the cluster. So the next question is, how do I promote between the environments? So I have separate environments, and they're watching for our different, what would you say? So let me rewind a little bit. Our dev environment is pulling from a completely separate Helm repository. It's pulling from a Git repository that's separate from our production chart repository. And then our production environment is just pulling from our production environment. So it's kind of, it's following our like standard CI process. When we're building our developer images, that happens, every commit, we build an image, it gets pushed up to our development repos. And then depending on how the environments are set up, they pull those images and pull those charts automatically. Some of them are using tags, like our RC uses Git tags, our previews use Git tags. And then when we actually publish a production image, that's like a whole nother CI workflow that publishes an image to our production repos, and then our production cluster just pulls the newest production images, right? Like when we put out a new image version, it pulls the newest one and pulls the newest chart. How do we monitor and manage vulnerabilities? With Anchore. That's a terrible answer, sorry. We scan all of our images in all of our CI pipelines with both Gripe, and we push them all to Anchore. And then we are continuously monitoring all of our production images as well using Anchore subscriptions. All right. I think that might be all the questions for me. Hopefully I answered them sufficiently. Handing it off to Dan Luhring now to talk about Syft.
Cool. Yeah, those were great questions, more than I thought we'd get. Cool. Let me move forward then. All right. So kind of interesting introduction of a few concepts. So we got a taste of what Flux is, and also, Anchore is using Flux. And so we're going to talk about kind of a fun symbiosis reciprocation in a second here. So first, just to catch everyone up, if you're not familiar with what an SBOM is, I want to just mention for one slide's worth of time what an SBOM is. So if you're not familiar, SBOM is this concept that's becoming more and more popular in the software community, particularly in the security space. And so SBOM is an acronym for Software Bill of Materials. The most popular analogy that people use, and I think is a pretty good one, is a list of ingredients for some software artifact. So if there's some kind of piece of software that you're downloading and running, maybe it's a container image, or maybe it's just some binary that you're about to run. The idea is that this is kind of like if you're buying some product from the grocery store, and that product is required to say what's in it with this ingredients list. And so I have this little example image here on the right on my slide. You can see the various ingredients that actually comprise the like outer wrapping of the thing that I actually bought. And so this ends up being pretty powerful, and it has a few different use cases that we'll talk about. But it's really important because just like with an ingredients list, there can be really impactful decisions that you make based on this information. So for example, with food, maybe I can't have any dairy, or I can't have any product that contains peanut oil or something like that. That might really matter for me, right? And so if I just see that I'm buying a candy bar, and I just see, oh, this says, name your favorite candy brand. It may not be obvious what it contains, but if I look at the ingredients list, I can make an informed choice about how I'm using that. And so I can decide maybe not even to use that whole thing, not to eat the candy as a whole, as sad as that would be. So the same thing kind of translates to the technology world, where it's, if I'm receiving some kind of software artifact, I can make an informed decision about if I want to use that or not. And so there's a few different use cases. Definitely by far the most practical one in security space today, the practical use of SBOMs would be for vulnerability scanning. And we can talk about this a little bit later, but it turns out that if you have a really good description of the software that makes up some outer software packaging, that's really, really helpful when you're doing vulnerability scanning, because vulnerability scanning is surfacing vulnerabilities in terms of those ingredients. So if you have some library X among your libraries that comprise your software, library X would have a vulnerability or not. So it's a really nice targeted way to identify where you're bringing in vulnerabilities, and from there you can decide how to manage those, et cetera. Maybe I'm tolerant of lower severity vulnerabilities, for example. But there's also some other usages without vulnerability scanning. Number one is just it promotes software transparency. So like I said, you can get a better sense of what software actually exists among your software stack. So a great example was this past December with Log4j. Those folks who had SBOMs on file for their software would either see Log4j in their SBOMs or they wouldn't. They don't have to go looking for it necessarily, as long as their SBOMs are up to date and high quality SBOMs, et cetera. So it becomes a really powerful construct when you're trying to understand what actually is running on your systems. And And then the other thing is policy. Of course, there can be policy about vulnerability scanning. You can decide that these software packages are introducing vulnerabilities that are too severe for me to be able to tolerate, so I can't allow the software into my system. But you can even have policy based on other attributes of the software packages that are listed in the SBOM, irrespective of vulnerability. So it could be, I'm not allowing any software from publisher X, for example, or maybe just some other software package, regardless of if there's vulnerabilities, I don't trust it, or I don't allow it, or we can't tolerate that. Maybe this is a government system and it can't have certain kinds of packages, whatever it is. There can be digests that you can do assertions on, content integrity. There's all sorts of stuff you can do with policy there. So that's the overview of what an SBOM is. Before we come back to how to actually use, kind of get into the weeds about an SBOM, now that you have a high level picture, I'm going to hand it back to Pinky just for a second to talk about SBOMs and the story there with Flux.
Yeah, so if you're not familiar with the CNCF, it's the Cloud Native Computing Foundation. It's basically an open source software foundation that promotes the adoption of cloud native computing. And within the CNCF, they have these maturity levels, there's sandbox, incubating, and graduation. So on July of 2019, Flux actually joined the CNCF as a sandbox project. And then in July of 2020, we were actually one of only 2 projects in the adopt category of CNCF CD Tech Radar alongside Helm. And then in March of 2021, Flux actually went from sandbox to incubation. And then in November of 2021, Flux actually underwent a security audit, and it concluded then in preparation for our graduation application. And the security audit actually sparked an internal review of our overall practices and supply chain, and it became an important point for us to improve on and provide better capabilities to our users. And so we were basically looking to generate SBOMs for all of our projects, provide ways for user to verify the integrity of our artifacts, and also secure those artifacts against tampering. The criteria was to use tools that were focused on the open source software ways of working, which quickly led to Syft for SBOM generation, with the benefit of having Gripe for vulnerability scanning and Cosign for images and artifact signing. So basically, both tools are actually integrated in Go Releaser, which Flux 2 uses for its release process. Being able to enable both features, leveraging the same tooling we had in place for 2 years with just a few settings, made the decision and adoption quite easy. And in March of 2022, Flux actually applied for graduation. So that's very exciting.
And just curious, what's the latest? Do you find out if you made it?
I think there's some discussion still happening. So we don't know yet. No, we have no idea.
Okay. But you shored up the SBOM piece, which is really great for you. So, all right, cool. Then I'll take it back over and kind of talk specifically diving into the details of what just happened here. So with Flux adopting SBOMs, what it was like for the Flux project to incorporate Syft, how hard of a lift was that? And then we'll kind of look at Syft up close and kind of reproduce a simplified version of this so that if you're interested, you can do the same thing for your own projects. So just brief orientation before we get into a live terminal here. These are screenshots just from the Flux project on GitHub. And so you can see that they're using Go Releaser, which is a really elegant way to structure a release pipeline if your project is using Go. It makes it really easy to like add or remove various steps that are pretty typical to find in a release pipeline using just a few lines of YAML here, as you can see. So what this is showing on the right here is that they had an existing Go Releaser process that was working for years. Pinky spoke to this. All they had to do was add what's in the red rectangle on the right here. So just a few lines, and all of a sudden they have SBOMs automatically being generated accurately using Syft for every release. So not bad in terms of integration effort, right? The only other bit that they had to do was install Syft. The way Go Releaser works is it has a lot of integrations, and it does so through binaries as opposed to like a direct Go import. And so the only other requirement is that the tools that you're going to use within Go Releaser are actually also installed. So you'll see here like customize, cosign, Syft, etc., buildx. And so again, just a couple of lines of this GitHub Actions workflow to get Syft. There's a GitHub action just for installing Syft, in fact. So that's really all they had to do. And then this is kind of the existing code where they had a release YAML. And so now that they have this running every release, they are now getting SBOMs attached to every release. And we'll look at an actual SBOM that they generated using this. So pretty cool. I'm feel free to interrupt me at any point, but I'm going to just walk through on the terminal kind of how some of these pieces work together. So without further ado, here's a demo. All right. So first, if you're not familiar, is this terminal font size? I should have checked this. Is this good enough font? Great. Okay, excellent. So the tool we're talking about is called Syft. And so Syft has a bunch of different options. But basically, this is a great little summary here. Generate a package-based software bill of materials, or SBOM, from container images and file systems. So Syft will show you a list of packages that are within the artifact that you're scanning. And that artifact can be a container image. It can be an individual file, like a Go binary. We'll show an example of that. It can be an archive, like a tar file or a tar.gz. It can be a directory, like if you've checked out a repo and you want to look about software that's described, like in your package lock.json, it looks for various signs of software, and then reads as much as it can and surfaces all that information. It doesn't make any decisions based on that, but it just surfaces as transparently as possible everything that it found in a well-structured way in various formats, depending on what you want. And then you can use that downstream for the use cases we talked about. So we're going to look at what that means. But so just to show you some examples, here I can specify a container image. And so if I specify, for example, Ubuntu latest, it will actually fetch that container image, open it up, look at the entire file system, do a search, and then find all the installed software and list it out here. Cool. Oh, Carlos is here. That is awesome. Okay, sorry for stealing thunder, but I'm gonna keep going. I'm just bragging about Go releaser, no big deal. This is a summary view of what Syft can output. And so ideally, an SBOM has as much information as possible based on the use case you're going to use it for downstream. And so this is the summary view, but you can run the same command. There's different output format options. So there's a couple SBOM standards like CycloneDX, and there's SPDX as well. Syft supports both of those. We also kind of have this plain JSON view that's just a proprietary Syft format that is kind of the raw like business objects that it found as it was doing its analysis. So I'll just show you for an example to contrast that simple table view that just showed the package name and the version with all the information Syft was actually aware of as it did the scan, just so you understand kind of the depth of analysis here. So this is just one package that it found, and it figures out the same information that it showed you before, the name and the version. It can also find associated locations on disk. Since this is an image, it's actually aware of which layer the artifact or the file system location it saw. So it knows that it was looking at the depackaged status specifically from this layer out of potentially many layers that it was observing as it split apart the image. It can figure out the license information, different kinds of identifications of the package like CPEs and pearls. And then it has also ecosystem specific information it can find. So since this is depackaged, it knows how to read the depackaged status file to pull out who the maintainer was. What files are claimed by the package, et cetera. So anyway, I'm kind of going fast here, but because I want to get to the Go releaser part. But this is just to show you that with Syft, you can get really rich SBOMs that are really useful for different workflows downstream. And this is part of what Flux, the Flux group noticed when they started their SBOM journey. So you can scan a container image. The other fun thing is you can actually scan Go binaries. So this is a fun example I like. Syft can literally scan itself. That which Syft just finds the path that I have installed Syft to. And so that's, in my case, it's a homebrew location. And so I can run this and actually see the software that comprises Syft itself. And this is, so it's a little meta, but it's just showing you that Syft is aware of what's inside Syft. Pretty cool. All right, so I'm gonna do a quick, very simplified Go releaser demo. And again, stop me if I'm going too fast or we wanna double click on anything, but this is kind of showing you what it would be like to do what Flux did if you want to apply this to your project as well. So to start with, I have a very simple Go app. I think Go app is a little bit generous here. These are the files in my project, right? So we have a very simple Go mod file. You can see that I haven't installed any dependencies at this point. And my program is very simple. I just print out, I love SBOMs, which is true. So I can run this. And sure enough, it prints it out. So that's great. And so now what I'm going to do is, right. Yeah, this is production ready. Very few bugs probably so far. We'll see. There's not tests to prove that, but it's only been a few minutes of dev time so far. So All right, so now what I'm going to do is actually introduce Go Releaser. So I'm going to run a really handy command called Go Releaser init. And this is handy because Go Releaser takes a config file, which is .goreleaser.yaml. But this go ahead and creates one for me. So now I can see I have a Go Releaser YAML that I can start editing. And now you're going to kind of see where that red rectangle was that we showed you from the previous slide in terms of what the lift is to start using Syft. So just to give you a taste of what Go Releaser could do, we can go ahead and look at that Go Releaser file. I'm going to simplify it a little bit just for the sake of this demo. We don't need this bit. What we are going to do is name the project. So we'll do project name, let's call it demo. All right, and I haven't actually added the SBOM excerpt yet. And so I'm going to show you what it does without that, just to give a feel. So to kind of do a simplified release, and so I haven't wired this up into an actual GitHub release project yet, but that's okay. I'll show you what it does just out of the gate. So it does actually a whole bunch of things for you for free out of the gate, which is super nifty. And so you can see here, it's kind of creating a few different things. Number one, it cross-compiled for multiple platforms automatically for me. So now this program that I wrote that's really powerful, that tells people that it loves SBOMs, is already natively available as a static binary for all these platforms. So Mac, Windows, Linux, multiple architectures. And then additionally, it was packaged up in an archive that can be shipped using these tar GZs. So that's pretty cool. And sure enough, I can see, if I look at my directory tree, I can see that it created this dist folder for me and has a tons of stuff. It has checksums. It has all these archives. It has the individual binaries. So for example, I could find this binary. In fact, let me do that over here. So let me go dist demo. I can actually find this and run that. Hey, I love SBOMs. I do too. Okay, great. So we'll quit out of that. Now what we're going to do is actually we'll remove that. We will we're going to add an SBOM section now, kind of like you saw in the other file. This is that little excerpt that you saw. And so now we're going to go run this again. And you'll notice another bit of activity popped up here, cataloging artifacts. This is a really cool feature, pretty recent for Go Releaser. It's actually cataloging the artifacts that it found. And in this case, these are these archives. So it's inspecting each tar.gzip file and creating an SBOM for each one. So now, if I look at the directory tree again, not only do I see these archives, but for each archive, I see the SBOM for that archive. So for example, I can find one of these. Let's take the first one, this Windows one. And I can actually inspect that. So this is what an SBOM actually looks like up close. In this case, this is an SPDX formatted SBOM, as opposed to CycloneDX or that proprietary Syft format I mentioned. And so you can kind of get a sense for what's packaged up in this SBOM using the SPDX format. And so in this case, as it lists out the packages, there's only one, because you'll remember that I didn't include any dependencies. So I just have the one package that is my program itself in this case, since this is kind of a simple view. But there's some really cool things that you still get. So for example, like one thing you get is some integrity checks. So you get an actual checksum value for the file itself. So that's really nice that the demo.exe that it found, Syft goes ahead if you want it to and calculates digest for literally every file if you want that it finds within an archive or within a container image. So it's pretty powerful. You can use this for downstream workflows to make sure nothing's changing as you have your chain of steps. And so that's pretty cool. All right, so that's kind of the quick demo. The only other thing I wanted to point out was going over here. If you're not familiar with Go Releaser, definitely check it out. The website's very helpful in showing you all the little things you would want to do. It has hooks for pretty much anything you can think of. If you want to automatically build Docker images and push those to Docker Hub or somewhere else. If you want to send notifications to various channels that the new release is available. If you want to automatically generate a change log for it. So these links are included in the slide deck that we'll send out. We also have a link to this particular part of the docs that show you how to use that SBOMs feature that I just showed you. This is the bit that's actually running Go Releaser in the Flux pipeline. And then this is the actual release that results from that step. And I just wanted to show you. So this is the latest release that's on the Flux GitHub repo. And you'll notice down here under release assets, I can actually see, sure enough, here's this SBOM that shows up in every Flux release now, which is super cool. So now Flux's users, whenever they want to, can inspect the actual software content of what they're receiving when they get Flux. And Flux is following a best practice here, which is to ship the SBOM right alongside where you're shipping your software. That's what people find to be the most useful. It's the most obvious how to find that list of ingredients for the candy bar. So if you imagine you bought a candy bar, but then had to go to like some other store downtown to find the list of ingredients, that'd probably be pretty inconvenient, and you probably would just end up not doing that. So this is great. Let's actually look at this. So grab that link. I'm actually going to grab that and save it out here. So now I have that, and so we can actually look at this. And so here's Flux's SPDX document. So analogous to what I just showed you, but instead of being for that very simple app that I wrote, this is the full-fledged actual Flux SBOM that they're publishing for their users. And so you can look at this, you can reason about this, you can use those judgments that we talked about earlier if you want to look at what software is included and decide for yourself if that's okay with you. So you can see the packages that are listed here. And yeah, so this is all the information that you would need. And with that, I think I'm ready for questions. That's kind of the end-to-end flow. Any questions about any of that? Yay. Oh, and I see, yeah, the Medium post that is mentioned, I took a look at it this morning. It's actually pretty good. And it's great timing because it's kind of showing kind of in more depth what we're referring to here with Go Releaser, kind of really looking at Go Releaser as this engine of leveling up your supply chain security. What is the difference between CycloneDX and SPDX? This is a question we get a lot. I think there's a few differences in how they represent data. We have found it's best to kind of try to support both on both the output and input. So Syft can output either, and we just announced earlier that earlier today that Gripe can actually ingest either for its vulnerability scanning. So I'm mentioning that in answer to the question because both formats do a good job retaining a lot of data that's relevant to consumers of this data. So if you're consuming an SBOM, you probably care about a few key things that let you do that vulnerability assessment, or just policy based on the software content that's described in the SBOM. And so most of the differences between Cyclone and SPDX are really about the exact like ontology, the exact kind of the taxonomy of key values. Exactly what something's called with SPDX might be different from CycloneDX. For example, SPDX focuses a lot on relationships and classifying different kinds of relationships, whereas CycloneDX focuses more on specific kinds of relationships like software dependencies. CycloneDX, I think they're also kind of focused on different use cases, or at least they were born out of different use cases, even if they're kind of converging in various ways right now. So SPDX was, sorry, I'm trying to read and talk. SPDX was, I think, originally created for helping businesses keep track of licenses of their software, whereas CycloneDX has traditionally been more focused on the security use case. But we're finding that both of them are working well for security at this point. We actually have a blog post coming out soon that details different results we get when we use SPDX and CycloneDX, and also the Syft format in various ways, particularly with vulnerability scanning. So I'll kind of save a little bit of the practical differences for that blog post. All right, let me catch up on questions here. Okay, this is cool. And we can show this stuff too. Okay, next, assume we are using Scratch-based images, so only the binaries in the image. Should we generate an SBOM for that container image, or should we generate an SBOM from directory before actually build the image? I think this is a good question, and I think I've seen a lot of discussions that ask the question: when should the SBOM be generated in like the traditional DevOps pipeline? So do I generate it from my raw source code before I build a thing like a Go binary? Do I generate it after I built the Go binary, but before I put it in anything? Do I wait until that binary is in my Docker image? And then, do I just wait till runtime where there's a running container that's mounted that file system, and now we're back to like a binary that we're looking at? My answer is it depends, which is a very easy way to kind of sound like I might know what I'm talking about. But I think what really matters is making sure you have enough information for the decision you want to make at the moment. So one classic debate, I think, is do you create SBOMs as you're building, or right before you build, or right after? That's kind of a particular framing I see for the question a lot. And I know folks have strong opinions in both directions, but for me, I think the answer is kind of both. There's advantages to generating SBOM information ahead of a build, particularly when the build itself is lossy. So there's information loss, there's metadata that's not going to be captured in the output binary, or maybe you wouldn't trust the information that did end up there. So a great example we see is like if you're doing some kind of like JavaScript bundling, you might have a really nice rich set of data because you have a bunch of package.json files for every node module you have. But then you do this, this bundling process with Webpack, and now you have a single like one-line JavaScript file that's like 50 megabytes and actually does contain a bunch of software, but there's no record of that software within that artifact anymore. That's an example where it'd be really good to kind of retain that information before or capture the information before you've done that lossy process. But also, I think on the consumer side, it is important to verify what folks are shipping. So if it's really important that you understand what software is being present, it's not a bad idea to generate an SBOM on the consumer side as well. So in the Go binary and container image example, I think it depends. If you're using a container-based workflow, and so you're consuming a container image as opposed to a binary, and you want to make decisions about the container image, I think it can be really useful to run the analysis on the container image, just because that's the exact artifact that you're using in question. That might be what you're verifying with Sigstore or something like that. So that's the thing you kind of have the knowledge about, the source of truth about, and then operate based on that source of truth, as opposed to kind of some sort of short circuit. It turns out that the SBOM should be similar in the two cases. So for example, one thing I didn't show is we can actually look at Syft, this example where I scan the Syft binary, which is just on my local machine. If you think about it, it really should be the same thing as this. And so this is a little bit different in terms of what's happening, because the latter example is, I just realized, am I still sharing my screen? I think I am. Okay. The latter example is fetching the container image that was published for Syft, doing the image unpack, looking at the file system, which turns out to be exactly what you were mentioning. It's a scratch image with just a single binary, plus the CA certificates. And so it looks at what's installed here. And if that's the same binary that we're also delivering on GitHub, then you would expect these results to be identical. And so again, it just kind of depends on what the consumption artifact is. Can I show a cyclone-dx SBOM? Absolutely. Okay, yes. So so for the project I just built, let's see. Let's take, actually, I have not done a cyclone-dx SBOM using Go release, or I know how to do it with Syft directly. Is that, let's see. Sorry. Yeah, let me just show you Syft directly for a second here. So, so we'll do SPDX versus, yeah, I'll do Syft. I think I'm going to use Syft anyway because it's a little bit richer in terms of an SBOM. There's actually dependencies as opposed to my dummy example that has no dependencies. So this is going to be a more interesting, useful comparison. So I'll do a split screen. On the left, I'll do SPDX. Oops, let me get that into a pager. And then on the right, I will do the same thing using cyclone-dx. So one thing to note, the actual hierarchy of objects and fields within each format is one thing, and then there's a different dimension is which actual text encoding is it using. On the left, you see what's called SPDX, but more specifically than SPDX, it's SPDX tag value. So you see a bunch of key value pairs organized into sections like this. On the right, you see XML. However, and the right is CycloneDX. But it turns out that both SPDX and CycloneDX also support JSON. So this might be a more like apples to apples comparison, quote unquote. So I could use CycloneDX JSON. And actually, I have a shortcut for getting that looking a little prettier. So here is JSON to JSON comparison of SPDX on the left and CycloneDX on the right. And so you can kind of see they both look similar at first. They kind of have introductory information about what format this is. Here you see SPDX, here you see CycloneDX. You see something about the version that was used. You see some kind of metadata about what was created. And then at some point you start to get into, you have a reference as to what was scanned. This is what was scanned. And they both scan the same thing, but they represent it a little bit differently, as you can see. And then we get into the actual software packages that are found. So SPDX, you see this packages section, and we begin to list the packages. The first one being this Go module called cloud.google.com/go. And then on the right, you see CycloneDX calls it components. And so describes it a little bit differently. And so I won't read off every difference, but I do think this is a really interesting, if you are interested in really SPDX versus CycloneDX difference, I think this is a pretty cool trick you can do just with Syft and just running it twice with different formats. You can kind of really see for yourself for a project that's of interest to you what the actual difference is. All right, let me catch up here. Yes, another mention is there's a recent feature for a command called Syft attest. That's as people are consuming SBOMs, one thing that's becoming more and more important is instilling a way to be able to trust that the SBOM has not been changed since the time it was created and truly came from the identity or from the person or company that you think it comes from. And so that's kind of like the next level up. SBOMs are a great step if you're not doing SBOMs, but what we can actually do is, if we want to take it a step further, is we can wrap the SBOM in this in like an outer data structure that is basically a way to sign the SBOM in such a way that references both the SBOM and the thing that the SBOM describes. And this is called an attestation. And you're going to start seeing attestation arise more and more. And so Syft has this command called Syft attest. And yeah, the link is in the chat now. And so this is really powerful. We're actually really excited about this. This is the beginning of Syft integrating with the Sigstore project. So Syft gets to use these Sigstore signing mechanisms to create an attestation. And that's really cool because you get to kind of get this guarantee before any SBOM bytes hit disk, and you start to not be sure if the SBOM can be modified. Right from the get-go, you have this nice signing envelope, and you can sign it with a private key and then provide a certificate or public key to your consumers, and they can decide if they trust your SBOM or not. And if you want more information, I won't go too much more into that, but there's a blog post that was mentioned in the chat for that. Is there a space requirement in the machine we are extracting? The short answer is yes. How much depends on what you're doing. And so there's various scenarios. Like, for example, if you're Syft, there are some scans where Syft will actually not need to take up any more disk space during its execution than what was already there. So if it can just inspect files as is in the scan target, like if you're looking at I think a tar file, a Go binary, most directory scans that are just looking at files like requirements.txt for Python or package.json, package.lock.json. There's a lot of scans where it doesn't need to copy the files anywhere or do any kind of inflation of archives. It can just read it as is. However, there's other kinds of scans where it does need to, like, decompress some files or copy down something that wasn't there originally, such as a container image that is pulling directly from a registry. It needs to park that somewhere on disk, and it's not just going to put it all into memory. So there are situations where you need to have some space available in the temp directory, and you can control where Syft uses which spot of the file system that Syft uses for its temp directory. would you typically install Syft on the build machine? Yeah, attestation is awesome. Thank you. Yeah, so regarding the build machine question, I think it depends again. I think generally, yes, if that's where you're creating the artifact that people are consuming, because I think in general, that's the SBOM that they're interested in, is the one that best describes what they're consuming. And where that's generated, I think can be debated. We mentioned that a little bit earlier. If there's a better SBOM being generated beforehand or right before the build, I think it can be convenient to do it right as close to the build step as possible. So on the same machine is great because you there's less opportunities for there to be a change between what Syft is analyzing and what's actually happening with the build materials. So I think there's advantages to that. But again, it can be useful to have an SBOM instead generated afterwards, or there's also ways to, with these formats, to have multiple SBOMs reference each other, kind of be merged. And so you can have the best of both worlds depending on what your use case is.
Thanks, Dan. I wanted to ask, just do a quick time check because we're coming up on the end here. So as we've done with past ones, we can hang out a little bit longer, but I just want to see if there's any last questions before we can kind of end the recording and let people go on, just keeping within our time bounds, or if there's follow-up discussion we want to have, we can hang out on Zoom a bit longer if there's specific topics we'd like to dig into. So is there anything else you wanted to cover, Dan, or did we hit all the highlights?
I think we hit all the highlights. I think I went into the weeds a little bit too much here.
No, it was great questions, and I want to thank everybody for those. It was a great discussion and awesome feedback. So we'll go ahead and officially say we're basically concluded here, and then if people need to go, we'll call it at the hour. But I'll hang around here, and I think that at least the Anchore folks, I can't speak for the Weaveworks folks, we can hang out a little bit and see if there's any follow-up questions that we want to answer for a few more minutes, and we have some time available. But I just want to thank our presenters, Dan and Pinky, and also Brady, our surprise in between presenter and Flux enthusiast. And thank you all for joining, and appreciate the questions and great feedback. So we'll go ahead and Brian can end the recording so that we're done with the official program. And if there's any additional questions that we want to hang around, we'll give it another 5 minutes or so before if there's interest, then we'll hang longer, but otherwise we'll go ahead and call it.
Sure.